All right. So we're, I think this is recording. We're taking a look at Skill 8F, and we've got, they introduced some trig identities to us that we're using for the first time. And I did problems 4 through 9 on a previous video where I really didn't use the trig identities. I just used my previous knowledge of the special right triangles, 30, 60, 90 degree, and 45, 45, 90 degree that I have memorized the ratios of I've memorized the sides of those triangles. And now I'm doing these problems again in a second version to illustrate that I can use various identities to do this. And I'm also going to use some of the previous answers as well. So if I look at cotangent of 45 degrees and they've given me the sine of 45 degrees, I have a quotient identity that tells me the cotangent of 45 degrees is the same thing as the cosine of 45 degrees divided by the sine of 45 degrees. And so I look up above here and they've given me that denominator. They've told me that the square root, that the sine of 45 degrees is the square root of 2. And this numerator was the previous problem. Now, it was written in radians, but I know that pi over 4 radians is equivalent to 45. So in problem 5, I found the cosine of 45 degrees. I'm not going to go through that work again. I've already illustrated that the cosine of 45 degrees is radical 2 over 2. So if I use that, I'm building upon my previous answers. If the numerator and denominator here are equal, this simplifies to 1. If you can't see that, I suppose that you could write it as division and then multiply, change the division to multiplication and multiply by the reciprocal, and you'll see that the 2's cancel and the radical 2's cancel. But I think it's pretty apparent that you can just go there directly, that this numerator and denominator are equal to each other. They simplify to the number 1. So hey, that's our answer here for the number 1, and we use the quotient identity and a previous answer that we solved in number 5 to get it. So let's take a look at number 7 here, tangent of 30 degrees. So again, my nature here, if I'm trying to use the trig identities, I have a quotient rule, quotient identity that says that the tangent of 30 degrees is the sine of 30 degrees divided by the cosine of 30 degrees. Well, I know that 30 degrees in radian measure is pi over 6. So they've given me this numerator up here. The sine of pi over 6 is the same as the sine of 30. This numerator is 1/2. Now, the cosine of 30, I think I've already done the cosine of 30, or the cosine of pi over 3. Let's look and see. That's not it. That's not it. I thought I did it. Cosine of pi over 6. Okay, maybe I haven't. All right, so let's see. Cosine pi over 6. Yeah, cosine. I just said cosine pi over 6. Yeah, we did cosine of 30. We did the cosine of pi over 6. I'm getting tired. Cosine of 30 degrees is radical 3 over 2 from problem number 4. I thought we'd already done it. So why go through and do it again? I've shown this in problem number 4 that this is the square root of 3 over 2. And the 1/2's cancel, or if you don't see that, 1/2 divided by the square root of 3 over 2. And I can change that division to multiplication by the reciprocal. So I have 1/2 times 2 over radical 3. I've got 2 divided by 2. I have 1 over radical 3. That rationalizes to the square root of 3 over 3. And there's our answer, and we're done. Okay. Let's look and see real quick what the next one is. Sine of pi over 3. Let's see. Have I figured out the cosine of pi over 3 or the cosine of 60 degrees in a previous problem? And nope, I haven't. Cosine pi over 6. Now I can use the identity that we did in the last section, and the idea here is that we are using identities. I know that sine and cosine are cofunctions, and I know that pi over 3 and pi over 6 are complementary, because pi over 2 minus pi over 3 is pi over 6, because if you get a common denominator, then the 3 pi minus 2 pi is 1 pi. So I know that the sine of pi over 3 is the same as the cosine of pi over 6, and I've already shown that that's the square root of 3 over 2 in that previous problem, right? The cosine, where'd it go? Cosine of pi over 6 is square root 3 over 2. We already illustrated that. So we can use our complementary angle theorem, or complementary angle identity, to do this as well. So there's a variety of ways to get these answers. Most of the time, the directions will be such that you're free to pick the one that gets you to the right answer. So hey, I hope that helps, and I'll talk to you later.